Okay, so if I have log, need markers. Looking at your problem 13. If I have the same base, remember, how would this look? Let's say 2 to the third equals 8, right? And how would that look as a log? It would be log base 2 of 8 equals 3, right? So if I have the same those two are the same number. Write this as an exponent. What would this look? I'd set it equal to x, right? And then I would say a to the x equals a to the 1, right? Well, on 7, I have, or 13, not 7, I'm sorry. I have log base 7 of 7 to the 29. If I set that equal to x, because I'm trying to find an exact value, I need to find out what does this equal. So I'm going to set it equal to x. And then on almost all of our log equations, our solution, our strategy to solve is to rewrite it as an exponent. So I'm going to say 7 to the x is equal to 7 to the 29, right? This is the same statement as this. This is just logarithm form and exponential form, right? So if my bases are the same, then x has to equal 29. And that's just a shorter proof of that one out of your textbook. Okay? Your textbook goes through a few more steps to prove if these are the same, this is all equal to 29. Right? No matter what. So if I'm looking at 14, I have base 2 of 2 to the negative 13. Because these two are the same, I could go through the step of rewriting it in exponential form, but you know that that is equal to negative 13. Okay? Once you establish these two are the same, the whole thing is equal to whatever that exponent is. So on 15, do I have two of the same? Yeah, because that's the natural log, right? Of e to the negative 4. Well, what base, when they do not have anything there, we know the natural log is e, right? So this is actually e to the negative 4. These two are the same, and it is equal to negative 4. Okay? All right, looking at, this is not my board at school. I can't do that. If I look at 17, I have 9 log base 9 of 13. This time, we're looking at this. Now, that's actually an exponential form, right? It is 9 to the exponent. So if I want to prove that, I'm going to write that as a logarithm because this is exponential. So I'm going to say log base 9 of x is equal to log base 9 of 13. Now what showed up the same? Log 9, log 9. That leaves me with x is equal to 13, right? So there's this property right here. E to the natural log of 8. That's an exponential form. Yes, the log is in there. The natural log is in it, but that natural log is an exponent. So if I wrote this, I would have ln E is equal to ln 8. And that gives me okay. When we talk about our exponent properties from days of old, a to the n times a to the m is where we add those exponents, right? Days of old right there have to have the same base. Well, on the inverse of that, I can go backwards. Remember, the answer to an exponent is. So if I have a multiplication, it can be broken down to an addition problem of m and n. Same base business is still there. So if I have log base 8 of 2 plus log base 8 of 4, because I have that same base, I can take this addition problem and make it into a single logarithm with a multiplication. I can rewrite this as log base 8 of 2 times 4. Oh, what's 2 times 4? So that would be log base 8 of 8. And what does the whole thing equal if those two are the same? What's the only number I can raise it to and it won't change? 1, right? This whole thing is equal to 1. We're going to use this one a bit more along with that one where we subtract. Multiplying and adding can get broken down to dividing and subtracting. And we already know from our exponent properties that adding and multiplying and dividing and subtracting go together. So what about 20? Let's see if you can come up with what you think 20. We need an exact value. Comes out to a rational number. What exact value did we get? Good. Log base 6, 9 times 4 gives me a 36. And it's not a matter of what am I supposed to do next, but really a thought process of what could I do with it, right? And 6, well, what could I do? I could write 6 as 6 to the second power. Now both of these are the same, and I used two properties. 1 and 2, right? The whole thing ends up equaling 2a2. All right. I'm going to take this out. And we're going to keep using those properties, so I'm going to leave. Come on. All right. On these, we've got 3 that we're going to use for the most part. All of them are going to kind of jump in there some, but mainly we're going to talk about multiplication and go back and forth with addition, division, and then we have our exponent one. Where is, right here. If I have m to the r, that comes down and multiplies in the front. So starting with problem 37, if I break that down, I have log base 6 of 36 plus log base 6 of x, right? 36 times x. So right in there, I can put a plus sign. Now what does that buy me? Well, we already figured out what's log base 6 of 36. That's a 2, isn't it? So this whole part of it can become a single exact value. And I would write this log base 6 of x. So using our properties to break that down, and we're going to use this to solve equations when we're in 6-6. But right now we're just we're in the solving equations where we learn to gather like terms and distributive property. That's the area we're in. What would you write for 38? That's a division one. So I'm going to be talking about breaking it into a subtraction problem. Minus now, not so much of what I should do, but what could I do? Log base 3 of x minus of 3 to the second power. So that's going to give me log base 3 of x minus 2 this time. 40, the only thing you're going to do is bring that 5 down front. What about 42? I'm kind of pushing on these ones that don't have a base because you kind of need to know what it is if it's not written in there, right? So that's the natural log of e minus the natural log of x. What number is not written in there that we need to know is there if it's not? For the natural log, it's e. If I have log log, it is 10, right? And that's important on this problem because those are the same. So that's 1 minus the natural log of x. Let's try out, what can you break down 45 to? Yes? 1 plus sign. Bring those exponents, anything raised to an exponent, down in front. This 2 is where this guy come from, and this 3 is where this one came from. Now looking at problem 48, how do I write the square root of something with an exponent? Instead of the square root of 1 plus x squared, it would be what? There you go. To the 1/2, right? So if I have the natural log of x plus the natural log of 1 plus x squared to the 1/2, the only thing else I can do to break this down is bring that 1/2 down front like any other exponent. Why do they have x is greater than 3 here? Can't have a negative. Can't have a 0. Cannot have the log of a negative number. So let's look at going the other direction with these. What we want to do with these is get them into a single log. So let's try if we can write 57 as one single logarithm. I want to write log 5 one time. Do we have calculators with us? I see some. We'll be doing our change of base here in just a little bit, and we'll go on a calculator when we do that. First thing I want to do is take this 3 back up to the u and this 4 back up to the v. So I have a u to the third plus a v to the fourth. Yes? And then this plus sign can get replaced. So I have log base 5 u to the third times v to the fourth. How about 61 here? First thing I want to do is take that exponent up. Then the subtraction becomes a rational, so I have 4x squared minus 1. Is there anything I could do? Is there anything up there you know what, that kind of could be rewritten as anything there we could break down? The numeric. That's going to be the difference of squares, right? So log base 4 of x, plus 1 times x minus 1. Well, x plus 1 is what I have in that denominator, isn't it? I could write that as x plus 1 times x plus 1 to the, if I took 1 out of there, I would still have a 4, right? And those will reduce. So now my final x minus 1, x plus 1 to the 4th power. To look at problem 62. Yes? But should I stop there or is there something else I could do? Okay. So I have x plus 1 times x plus 2 because this trinomial will factor. I'm going to take x plus 1, x plus 1, x plus 2 over x plus 1. Yes? And I guess I'm just used to it. There really is no reason to have those parentheses there. Okay? Again, what can I do? Okay, be asking that. All right. The last thing we're going to talk about today is when that base wasn't written there, you can't punch that into the calculator. Okay? It doesn't do log base 3. If you hit log 8, you're going to get the answer to log base 10 of 8. Right? It's not going to tell you what log base 3. There's no place to put that 3 in. So if you're going to use this, if you're going to solve this, you're going to have to use your change of base. And that is right here. Okay? You're going to have to make a ratio. And it doesn't matter, because it's a ratio, it doesn't matter if you use your LOG log or your natural log LN log. If I'm going to do log base 3 of 8, the 8 is up in the numerator. And what I'm going to use on my calculator is I'm going to say log 8. And then divided by log 3. Now your calculators are going to be different. Some of them you're going to put the log button first. Some of them you're going to put the 8 in first. Some of them you're going to have to use parentheses. What are we getting for log base 8 divided by log base 3? You guys got to tell me, because I don't have a calculator with me. No one? Yes? Did we all get there? All right, so we got an agreement. Your calculator is using this as a base 10. Now, if you want to use your natural for whatever, just because it's a ratio, you'll still get that same answer, right? All right, let's try a couple from your problems here. Of 21 is going to be like I said, you're probably going to have to use some parentheses sometimes. Let's see. Funds. All right, so I'm cheating. Textbook says 2.771. Did you get that up on that calculator? All right, let's try one where you're going to have to probably use those parentheses on your calculator. So how about 75 square root of 2? So we need and I think you're going to want to put before you hit that equal button, you're gonna wanna put that second one. And get your log 7, divided by button, open up parentheses, and close it. And this is more about using that calculator, so what we're working on is trying to get, that is 75, right? 5.615. Were you able to make that appear on that screen? We don't want to try to figure out how to use the calculator with these on test night. So, okay. So N65. 6. 11, 12. Under the rug. Can be done. Okay? We got questions. I'm here. I'm not going anywhere. Otherwise, if you're good to go, you're good to go.
What is your backlog?
26th.